Hi everyone. I hope everyone is doing wonderfully as always. Today we're going to be solving this problem from LeetCode, which is invert binary tree. It says that given the root of a binary tree, invert the tree and return its root. So we've given a root here in this function, which is tree node star root, and then we need to invert the binary tree. So what does it mean by inverting the binary tree? Well, if you see it here, the four root has not been changed, right? But if you look at the children of this node or the root tree, the 2 and 7 left and right child has been swapped to 7 and 2. So it's basically they inverted. I think that's why they reversed, or you can say the inverse, maybe that's what the invert means. And but remember that inverse and reverse, those are different things, but we kind of getting the idea. So it's basically reversing, or you can say inverting a tree. So 2 and 7 has been swapped. So in this first level nothing has been changed, so the root remains same. But in the second level of the binary tree, the 2 and 7 has been swapped, right? Now in the same case, if you see it here, in the third level 1 3 6 9, they have been swapped to 9 6 3 and 1. So basically you can also assume it like this. I'm gonna show it here. So if you see it here, the root remains as it is on this swapped tree, but their children on the second level 2 and 7 has been swapped to 7 and 2. Same as 1 3 6 and 9 has been swapped to 1 3 6 and 9 from the reverse order. You can also think of it like this: if this is your one branch, and if this is your other branch, basically those two branches have been swapped, right? Because if you see it here, you have 2 1 and 3 and 2 1 and 3 on this side, and then 7 6 and 9, 7 6 and 9 on the left side, but previous one has it in the right side. So that's the idea. So how do you actually solve this problem? Well, if you know some traversal of a binary tree, it's going to be easier to solve it. It is basically a swapping two nodes, right? So you also need to know one simple function, which is swap in C++. If you pass any two values here, it will get swapped in this particular function. So I'm going to be using a level order traversal here, which is going to be level order traversal. If you don't know level order traversal, I have already uploaded the video regarding this level order traversal. You need to watch that before you actually solve this problem. So if you don't watch that, I will try to explain it in an easier way. So even though if you don't watch it, you will grasp the idea. But it's better if you watch it. So the thing is that we will traverse our binary tree, which is this one initially, and then we'll go to the root, right? And then we need a queue in our level order traversal. So we need to go, we'll go here and then we'll store our root here. Then we will swap its left and then the right child, which is 2 and 7. So 2 and 7 will be swapped to 7 and 2 in this case, and then I will check if the root has a left child or no. Since it has a left child, so I'll store the left child here, and then right child, which is 7 here. And then also I will pop this 4 from my queue. Now since I already swapped 2 and 7, I will check my queue again. Since it has 2, I will go to 2 and then I will pop it from the stack, right? Before popping it from the stack, I will swap its node. So since 2 has already been swapped and then it is here in this case, don't look at this label because this has already been swapped to this particular scenario, right? So 2 and 7 has been swapped to 7 and 2, right? You will basically use this swap function. I will write directly in the code to show you all. Since this is already swapped, it will check 2 in the queue and then it will swap its left and then the right side. When it swaps that, initially it has 1 and 3 in here, right? When it swaps that, it will basically change it to 3 and 1. After that, it will store their children in the queue and then pop it itself from the stack. Now since we have 7 in our queue, sorry, I said stack, it's queue. Since we have 7 in the queue, we will go to 7 and then check its left child and then the right child, and then simply swap it to 9 and 6 instead of 6 and 9. We swapped it right here, and then we will remove 7, and then we will store 9 and 6 like that, right? All right. Now, if you see it here, if you see one thing, we will go to again 3, right? But if you go to 3, 3 doesn't have any left and right child, so we don't have to swap anything, or we can simply say we will return whenever our root is null. So we will pop this one too, and then we will go to 1. 1 doesn't have left and then the right side, so we don't push anything in our queue, and then we will simply pop this one too, and then likewise we can pop everything from our queue as soon as we reach the last level. So that's how we can solve this particular problem. Okay, so let's try to convert this idea into the code actually, right? So in order to do all level order traversals, you need to have a queue, which is going to be node star and then queue, and then we will check if our queue is empty or not. So we'll say if our queue is not empty, before you will go to the while loop, you will pass your, or you will push your root in the queue, right? So that you can process it. Now you will check three nodes are current is going to be queue's front, because you have the root in your front, and then as soon as you do that, you can simply pop the value from queue, because the root has already been transferred into the current, right? Now you will simply do the operation here. You will simply say swap currents left, which is these two value has been swapped to currents right, right? This has simply swapped, so it's already 7 and 2 now. As soon as we do that, we'll check if our current has a left or no. If it has, we will simply push it into the queue. So queue dot push currents left. Again, we will check if the current element, which is 4, has a right child or not. If it has, we will also push that in our queue, right? As soon as we do that, this is it. We don't have to do anything from it now, because this will simply push 2 and 7 in our queue, and then again go to the queue and check if my queue is empty or not, and then it will get 2, and then again swap its value, and then like that it will get every value in our queue or the root will be swapped. After that, I will simply return the root, because the question says return its root. You also need to check one more thing here, which is going to be if your root is going to be empty, which is going to be if your root equal to null, you will simply return null here. That's pretty much okay. Let's try to run this code. Hopefully it should run. All right, so every test cases has been successfully ran. Now we will submit the code, and then let's see if it gets submitted or not. All right, everything has been submitted successfully. I hope you understood the problem. If you didn't, please watch the video again, try run it multiple times on this given example, and then I'm 100% sure that you will understand it. Thank you so much for watching the video. I will try to upload these kind of videos anytime soon in the future.